Everybody, we have another one of these no calculator type problems, but it's not as hard as you may think. If you take a look at a very natural looking substitution right here, this number I'll say at once, 5,566,778 is one more than this number right down here, the one that I won't try to pronounce, okay? So that's a minus 1 quantity squared. Right. And right here, of course, this is this number incremented by 1, and so you would have a plus 1 quantity squared. All right. So that gives us some hope on something that would be quite intractable if you had to do it by hand. Okay, so let's move along. Using that substitution I just mentioned, okay, we reach this stage down here, and let's finish it off, see if something nice happens. You would anticipate things canceling, and indeed they do, based on a minus 1 quantity squared and a plus 1 quantity squared. This would be equal to a squared in the numerator, of course, remains unaltered. Okay, now this binomial expanded gives us a squared minus 2a plus 1 Okay, again, that's this object squared. Now we have plus, just the, it's very similar in structure, but you can see nice things are happening already. That's a squared, not minus, but plus 2a plus 1. And of course, that's, don't forget the minus 2 that's dangling out there. Okay, but let's see what happens now. We can see very quickly that a lot of stuff cancels. These 2a terms cancel. And this 1 plus 1 is equal to 2, which will cancel with this 2. And so we actually end up with a squared. Now notice we have two a squareds in the denominator, so this is a squared over 2a squared, which simply cancels out to 2, provided a is not equal to 0, which it's not. So you can make up as many problems as you wanted in this form, folks. Giant numbers, small numbers. Anyway, that is the solution. Again, algebra, using algebra to minimize the computational burden. So this is identically equal to 1/2 for all a not equal to 0. Thank you for viewing.